In this video, I'm going to be talking about how to solve an equation. I'm going to show you 4 examples that get progressively harder, starting with one that's fairly simple, and then a fourth one that is going to be a little bit on the difficult side. So if you draw your attention to the left over here, I have a few steps that you want to make sure you have in mind before approaching these problems. Number 1, when you see a problem, you want to see if there's any cleaning up you can do. And what I mean by that is basically taking what you have in front of you and making it look a little bit more simplified, and that'll make a little bit more sense once you actually see me apply that in one of our equations. The second thing, which is basically like the main process of solving for a variable, is you have to keep the sides equal with opposite operations. So we have a few different operations, the main ones being adding and subtracting, multiplying and dividing, and then occasionally you'll have squaring and square rooting. And then finally, you just want to make sure you isolate the variable. So whatever variable you're looking for, isolating it means basically having it on one side of the equal sign by itself. So our goal is to basically move everything away from our unknown variable so that we have x equals and then some number on the other side. Okay, so the most important thing to really understand is, why do you do the same thing on both sides? So if you draw your attention to this scale over here, so say, for example, we had 10 marbles on each side of this scale, then it would be completely balanced. So over here, if you're taking a look at a formula, it says it's equal. If you're taking a look at another example over here, it says it's equal. That means both sides are the same thing, whatever that may be. So say, for example, if you had 10 marbles on this side and 10 marbles on this side, if you add 2 marbles on the left, then you have to add 2 marbles on the right, or else they're not equal, and it's going to tip the scale to one side or the other. Okay, so that's why you always do the same thing to both sides, because you want to make sure they maintain equal. You want to maintain that balance in the scale. Okay, so with that being said, let's go ahead and get started. So the first one, we have 3x minus 10 equals 4 plus 2x, and I could really cancel out this 3x or the 2x. What I'm going to do is decide to move the 2x first, but it really doesn't matter the order you go. So I'm adding, so I want to do the opposite, which is subtracting. So subtract 2x to one side and subtract 2x to the other side. So if I do something to one side, I always do it to the other, and that cancels out my 2x, and 3x minus 2x is just 1x. So I could just write that as x. Okay, and I still have minus 10 equals 4. Okay, from there, again, remember my goal is to isolate the variable, so I want to get this all by itself. So I want to get everything away from it. So I'm going to do the opposite operation. I'm going to add 10 to both sides, and then this minus 10 and plus 10 cancel out. And then my answer is x equals 14. Okay, so the things that you want to stay consistent with is always do the same thing to both sides, and then always show your work. Okay, so don't do stuff in your head, because eventually you'll get tripped up when you work on things that are a little bit more complicated. So you want to make sure you stay consistent with the process. Okay, my second one, I will do a little of this cleaning up that I mentioned before, okay, because this is a little messier looking, so I can clean up a little bit. I have a fraction and I have stuff in parentheses as well. So what I can do to maybe change it up a little bit is I can keep this side 5x plus 3. There's not much I can do with it. And then I could distribute this 2 over to this one and over to that one. So then that's going to be 2 times x, which is 2x, minus 2 times 2, which is 4. Okay, so I like that. That looks a little bit nicer to me. I don't have to worry about the parentheses and distributing stuff later. Okay, and then I have everything divided by 3. All right, so that cleaned it up just a little bit. I still want to get rid of that fraction. So as I start my problem solving process, I want to make sure I get rid of that 3 first. So I wouldn't want to add this 4 or subtract this 2x, because they are both divided by the 3. So it's actually 2/3 x minus 4/3. So to make things a little bit more simple, I'm going to get rid of that 3. So I'm dividing by 3. The opposite is multiplying by 3. And then I multiply this entire side by 3. Okay, so 3 over 3 is 1, which basically gets rid of it. 3 times 5 is 15, so that's 15x plus, and then 3 times this 3 over here, which is 9, equals 2x minus 4. Okay, so now I've made it into something that resembles this a little bit more, which is a lot more manageable. I got rid of my parentheses, I got rid of my fraction, and now I'm ready to continue on. So I'm going to decide to subtract the 2x from both sides because I'm slowly trying to scoot stuff over to one side. Okay, and the reason why I subtracted the 2x from both sides is so I can keep the x positive. And then same thing with this over here, because if I subtracted 15x from both sides, that's going to leave me with a negative 13x there, which would be fine and would still give me the right answer. But I just like to avoid negatives if I can, but it's not totally necessary to do so. Okay, so this cancels out. We got 15x minus 2x, which is 13x. We still have our plus 9, and we still have a negative 4 over here. So we're going to finish off by doing two more things. We're going to subtract the 9 because we're adding the 9, so that's the opposite. That would leave me with 13x equal to negative 13. And then we finish it off by having both sides divided by 13. Okay, because when their two numbers are right next to each other, you can always assume that they're being multiplied. So I'm going to divide each side by 13, and then negative 13 over 13 equals negative 1. That's my final answer. Okay, so if you're only working on basic algebra, that's probably about all the skills that you will need to do the problem solving that you have to do. I'm going to do two more examples that are slightly more complicated. So if you are doing some algebra that is a little bit more complicated, stay tuned. If all you needed was the basics, then you're probably good to go. Now for the final two problems that are slightly more complicated, I'm going to see if I can do any cleaning up. For this one, I can do plenty of cleaning up. I can square the 9, which is 81, v squared. I'm going to leave it at that. And then for these three, I can multiply them out. When you're multiplying multiple numbers, it doesn't matter the order in which you multiply them, so just go ahead and do it. So 2 times negative 10 is negative 20. Negative 20 times 3 is negative 60. Okay, for this one, we're solving for a v. It doesn't matter if you're solving for a v or an x or a y or a z. Most people are accustomed to the x, so it throws them off when they have a different variable. So I just wanted to show you the problem solving process without using an x. So I want to isolate my variable, so I have v squared plus negative 60. So I can go ahead and add 60 to both sides. That will cancel out my negative 60, and that will leave me with 141 equals v squared. Okay, and as I mentioned before, the opposite of squaring something is the square root. So your final step would just be to square root both sides. And then you can say the square root of 141 equals v. So that would be your exact answer. If you want to plug it in and then turn that into a decimal, you can call it 11.87 as your v. Okay, that's a little bit more of an approximate answer, and then this is the exact value. Okay, so let's go to our very last one. The last one, we are still solving for an x, but we're solving for an x in terms of z and y. So anytime someone says in terms of, that means that part is included in your answer. So if I say I'm solving for x in terms of z and y, that means z and y are going to be sitting in my answer. Okay, so let's go ahead and take a look at this problem. I can do a slight bit of cleaning up. 8x times x is going to make it x squared plus z equals 5y. Okay, so you have to remember, although it looks like there's a lot more variables, which there are, you're going to treat the z and the y basically like numbers, because they are numbers, they're just unknown numbers. So I'm going to go ahead and start scooting some stuff over. I'm going to scoot over the z because I'm adding it. I'm going to subtract. And then that's going to leave me with 8x squared equals 5y minus z. Okay, after that, as I said, I want to keep on scooting stuff away from my x, so I have 8 times x squared. Anytime two numbers are next to each other, they're being multiplied, so I'm going to go ahead and divide those and divide both sides by 8. Okay, and as it looks now, we have x squared equals this entire value over here. And just like we did on this side over here, anytime you have a squared value, you want to square root it. So once I square root my x, then I'm going to square root this entire side. And then my final answer is x equals the square root of 5y minus z over 8. Okay, so the steps to keep in mind is if you can simplify the look of your problem, that is definitely beneficial. So do a little bit of cleaning up to start it off. After that, remember, you don't want to tip the scale, so to say. So you want to make sure you do the same thing to both sides to keep that equation equal. And then as you do that, you will do the opposite operations to scoot stuff around. And if you keep on scooting stuff over to one side, you will eventually isolate the variable and then solve for your unknown variable. So I hope that was helpful in helping you understand and solve some equations. Thank you for watching and listening.